Okay, so today we're going to do a hyperbola. So a couple of things that we have to remember about a hyperbola is, and that's very important. When I get a Cartesian plane, and I've got a hyperbola in these two quadrants, then my a is always bigger than 0. And if it's in these two quadrants, my a would be smaller than 0. So that's very important. And then obviously I've got asymptotes. Now when it's in standard form, this refers to my vertical asymptote, and this refers to my horizontal asymptote. So that's very important to know. Okay, so let's start off with this. And they've given me this function. They say g of x is bx plus c, and they've got f of x is a over x plus b plus q. And so it refers to these functions. One of is a straight line, the other one is a hyperbola. And let's start with the first question. It's they ask, write down the equation of f in terms of a. So whenever I write down the an equation in terms of an unknown, just make sure that your answer do have the unknown in. So this was the equation. So we need to write down the equation. So this is 6.1. So this is the equation. This is the equation for the hyperbola. So the only two values I, in theory, need to fill in is my asymptotes. Now, this p refers to the vertical asymptotes, which is currently at -3. So we always have to change that sign. No? So this becomes x plus 3. So the vertical sign, we always have to change the vertical asymptote. But the horizontal one, we're going to keep as is. So that would be my new equation in terms of a. Okay, and they do go further in 6.2, and they ask us to find the value of a. Now, to find the value of a, remember this, always when you need to find the value of an unknown, just sub a point into that into the equation. And do I have a point? And remember that they've given me this coordinate over here. C is a point on the hyperbola, so I can actually sub that point in. So I'm just going to start off by subbing that -2 and 6 into my equation. So where every x is, there's a -2, and where every y is a 6. So 6 equals a over -2 plus 3 plus 1. And then we're just going to solve for a. So a is over 1 plus 1. Let's take the plus 1 across. It becomes a -1 on this side. So this is 5. So it's actually easy from here. So a is 5. And we actually found the value of a as well. So we can, in theory, go and write the values in over here. So let's just do this whole equation. We've actually found a as 5. Okay, so we're going to punch in 5 over there, and we're just going to keep the asymptotes as it is. So nothing changes. Okay, so that's 6.2. So let's go to 6.3. Let me just make a bit of space. So whenever you do work out something, you just have to tell yourself, keep on reminding yourself to put it back into the original function, or draw it into your sketch or something. So make sure that when you work something out, just go and fill it into your equations and mark it on your sketches. Okay, so 6.3, determine the coordinates of the x-intercept. Now the x-intercept is, you know where this is. This is this point here. And they're asking for f's x-intercept. So what I'm going to do, I am actually going to make y 0. So we'll write down the y x plus 3. Remember that when you want an x-intercept, you make y 0. If you want a y-intercept, you make x 0. So we're just going to so we're looking for x-intercept, so we're going to make y 0. So this would be 5 over x plus 3 plus 1. We'll take the 1 across, and we're just going to solve for x. So we're going to crisscross multiply over here. So whenever there's an equation, and there's a fraction on the one side and a fraction on the other, you can just do your crisscross multiplication, or you can find the LCM, either or. and then obviously this 1 times 5 is just 5, so this is minus x minus 3 equals 5, so minus 1x equals 8, so x equals negative 8. And so we need to find the coordinates or the x-intercept of f. It is at a, so my a coordinate would be negative 8 and 0. So in 6.4 they ask us to find the values of A, B and C. So it refers to my straight line. So I'm just going to write my straight line down, where B actually is my gradient, M. Okay, makes sense. Okay, and I need to find the value of B and C. So let's just highlight whatever we need to work out. We need to find the value of B. We need to find the value of C. Okay, so those are the two things we need to work out. Okay, so how do I find it? So for a start, I need to find B. And how do I find B? By working out the gradient. Can you remember? So we'll find the gradient of which point? AD. So if we find the gradients of AD, we'll have y minus of A minus the y of D over the x of A minus the x of D. Okay, so what was the y of A? Was 0 minus 1, and minus 8 minus 3 becomes a positive 3, so this just become a fifth. So my gradient is, so B, so in B theory this is B, so it's a fifth x plus my c. How do I find c? We're just going to sub a point in. Remember that whenever you find you need a variable and you need to work it out for unknown, we're just going to sub a point in. Do I have a point? Yeah, and obviously we can replace any one of the two. We can either sub in my minus 8 and 0, or we can sub in the d coordinate of minus 3 and 2. So y would become a 0, x would become negative 8 plus c. So you'll find c as 8 over 5. If I didn't make any mistakes, it doesn't look like it. So in fact, what was the question? Determine the values of b and c. So we actually found the values. That's the b value and that's the c value. So we just found it. They didn't ask for the equation. Oh no, they say write down the equation. I can see it. So basically we're just going to rewrite this equation. Let's just do it on this side. Y equals a fifth x plus 8 over 5. And that's my equation. I'm just going to rectify this quickly. Because I found my b, I found my c value. My b value was the fifth, and my c value was 8 over 5. So I'm just going to put it back into my sketch and my original equations. Because I will probably need that to find the other equations or do the things around it. Okay, so we've done 6.4, so now we're going to do 6.5. 6.5 is write down the domain of f. So the domain refers to all the x values, and you have to remember this. Whenever I've got a hyperbola, it will be always x element of real, but it excludes my asymptote. And even when I do my range, it would be y equals element of real numbers, but it excludes my asymptote. So that's very important. So this was an easy one. So whenever we do the domain, x element real, but it excludes my asymptote. My asymptote at the moment is at negative 3. So it's all those values. And okay, so we've done 6.4, we wrote down the domain, and now we did need to do 6.6. So 6.6 asks for the coordinates of b, which is the intercepts of the two functions. And what do we know when we've got the intercepts now? We're going to take this g of x, and we're going to, and because those two functions are equal at those intercept points. Okay, so let's write down my g of x. My g of x is a fifth of x. I'm going to put x always at the top. You know, when you do fractions and you've got an unknown, you're just going to put that unknown as the denominator. Okay, so that's a fifth of x plus 8 over 5, and that equals to my g of x, which is 5 over x plus 3 plus 1. I'm just going to put the 1 as 5 over 5 for now. Okay, so I'm just going to simplify slightly. I'm going to keep these x's as they are. We're going to do an LCM at the moment, just after this. But let's just simplify these two. So I'm just going to take that negative 5. Oh, let's bring the 5 over 5 to the left hand side. Becomes a negative 5 over 5. So that will actually give me 3 over 5. No? Now it becomes easier with my LCM. So my LCM is, so the LCM at the moment is 5 and x plus 3. So now I just need to rectify my nominators. So the first term over here, I had a 5, and this one I have 5, so both of them need the x plus 3, so let's just fix this. So this one needs the x plus 3, and this one needs the x plus 3, and my 5 needs the 5. Makes sense? So we're just going to simplify this. Plus 3x plus 9 equals 25, and just simplify everything by making one side 0. You have to remember, as soon as I see any equation with a power of 2, I have to make it 0. It's not negotiable. So this becomes plus 6x, and 25 comes across, and that becomes a negative 16. Okay, one side is 0. We can factor out. Okay, this easy, a plus and a minus, and I'm just going to rush through this, and you can take your time and try to do that. Try not to use your quadratic formula when you can actually factor. They might penalize you, not necessarily, but if you can factor out, why use that formula? Okay, so we've got x equals to negative 8, or x equals to 2. Okay, I know that the negative 8 is not applicable because I've used it on this side. It's because there is 2 points of intercept. So I know that my bx, my coordinate of b, the one that I had to work out, x is 2. So we just need to sub that 2 back into, so this is the one we're going to use. So we just need to sub it back into one of the formulas, and just let's use a straight line. So the straight line was 5, we know what the x is now, plus 8 over 5, but you can sub it into any of those points, and then so that's 2 over 5, okay, so it's 10 over 5, which makes it 2. So I've got the coordinates of b, which is 2 and 2, and I think that was the question. Yeah, find the coordinate. Okay, so the last question, 6.7, that's quite tough. So let's just think what they ask. They're asking, where is x times f of x, meaning a y, greater than 0, meaning gives me a positive answer. Just think of this again. Where's x times f of x, which is a y, greater than 0, meaning a positive? Okay, so let's think of this. If I've got a Cartesian plane, and these are all pluses, and these are all pluses, so my y values are plus, and my x values plus. If I multiply this x with this y, I'll get a plus. So that is perfect. And also in this quadrant, because that's all the negative, if I take my x and I multiply it with my y, my negative and my negative, I'll also get a plus. So when they ask these type of questions, where do I get x times f of x greater than 0? No, meaning in greater than 0 plus, they're referring to quadrant 1 and 3. If this question was the other way around, they would have referred to these two quadrants. Okay, so now we know what quadrants we are talking about. Okay, so let's color them. Okay, so let's color those quadrants. So we're going to color the quadrants. We're going to say, this is my first quadrant, and anything in this quadrant is positive. Let's go to there, sorry. Also, I saw the asymptote there, sorry about this. So that's the quadrant, no? And the other quadrant is over here. Okay, so what are they asking? They're asking, where's this function? So I'm just going to highlight the function, and I'm only going to highlight it in those quadrants. which I'm coloring. So think of this, now I wanted to make it red. See, this is my function, but it's not in quadrant 4 all the way. It's only in this piece over here and this piece over here. So I'm just highlighting my function, and in its own, that's where those functions are in those two quadrants. Now I just have to give it my answer. I'll just say 6.7. Okay, so for which values of x? So we're going to say x. Can you remember that x coordinate was minus 8? So x would be let me just move it up a bit. So x would be greater and equal, because there's an equal sign, than 8. But it's definitely going to be smaller than 3. And it's not going to touch because, remember, this is an asymptote. So it's moving towards 3. Okay? That's very important. Okay? And so that's one of the points. Or remember, and then anything from 0 onwards, it's going to stay positive. Or x greater, is it equal to 0? Let's think of this. Raak hy die 0? Yeah, does it touch the 0? Yes, it does. So it's all the way from negative 8, sorry, I wrote 8, negative 8, up to 3, and then from 0 onwards. Hopefully that makes sense.